Alright, so today we're going to talk about solving absolute value equations. We've looked at the graph, we've analyzed the graph, and some key things to remember from analyzing the graph in our previous lesson is to remember that an isolated absolute value cannot equal a negative. Okay, remember we looked at the graph and we saw the parent function, the y values were never going to be negative. Also need to remember that when we looked at the graph also that for every y value there was two x values. So that means when we're solving for x with each y value given, we're going to have two answers, okay? So absolute values. Remember that. So we're going to be solving these and when we check our answers, you can either use Desmos or you can use the calculator. I'm going to use Desmos because you can't see my calculator. But if you would like to use the calculator to find the absolute value function, you are going to go to Math. You tab over to the number tab, and then you scroll down to number 1, and it's going to say ABS, which is absolute value. And that's how you get it in your calculator, okay? All right, so 5 easy steps in solving, okay? The only thing really new in solving is going to be step 1 to 3. The rest is going to be solving for x, which you've done in Math 1 so much, and in Math 2. Okay, so step 1 is isolate the absolute value. You want to ask yourself, can it happen? And what do I mean by can it happen? Again, I said, remember from the graph, an isolated, that's the key word here. I need you to remember that word, isolated. Absolute value cannot equal a negative number. So things to talk about. Can this happen? Can the absolute value of x equal negative 3? Well, the absolute value is always going to produce a non-negative number. So if you take the absolute value of negative 3, you will always get positive 3. So no, this cannot happen, okay? Let's talk about the word isolated. So an isolated absolute value looks like this. Let's just say 3x plus 2 equals 4. That is an isolated absolute value. See how there's nothing in front of the absolute value bars, there's nothing behind the absolute value bars, okay? Now, a non-isolated absolute value is going to look like this. 3 times 3x plus 2 minus 5 equals 4. So you see how there's something in front of the absolute value bars and there's something behind the absolute value bars. That makes it a non-isolated absolute value. So the only one that cannot equal a negative is an isolated. An isolated absolute value cannot equal a negative, okay? And you have to get your absolute value isolated before you can solve so you can see if it equals a negative or not, okay? So you never solve a non-isolated absolute value. That's why it can equal a negative. You have to get it by itself and then you can start solving for x, okay? After you do step 1, you determine can it happen or can it not happen once it's isolated. Then you have step 2 and 3. And step 2 and 3 kind of happen at the same time. So you set 1 equal to the original version, the number. So you set 1, so for this example, you would set 3x plus 2 equal to 4. And then you would set 1 equal to the opposite version. So then you would say 3x plus 2 equals negative 4. Because remember, the absolute value of a number has 2 answers. Okay, so therefore we have to set up 2 questions to get our 2 answers. Okay, after that you're going to solve for x. Okay, and then you need to check your answers. Okay, it's just a quick type into Desmos or a quick type into your calculator, but always check your answers because we're getting into the higher level maths where you can have answers that are not really answers. They're answers algebraically, but when you look at the graph, they don't happen. And so that therefore we call them an extraneous solution or not a solution. Okay, so you really need to start checking your answers now if you haven't been before. So let's do some examples. So number 1, okay, is the absolute value of 3 minus 4x equals 23. Okay. Now, this is an isolated absolute value, so we don't have to do anything of getting rid of anything before we set up our cases. It equals a positive 23, so we're good on that one also. All right, so let's set up our cases. So the first case says to set it up equal to the original version. Now, when you're setting up your cases, you don't need absolute value bars anymore because we're getting rid of that by setting up our two cases. Our two cases fulfill the absolute value bars. It's kind of an equivalent situation, so you don't need them anymore. It's just like when you say 2 plus 3 equals 5. Once you say 2 plus 3, you get rid of the addition sign, okay? Or the square root of 4. When you take the square root of 4, it's 2, plus or minus 2, really. You got rid of the square root because you handled the operation, okay? So our first case is going to be 3 minus 4x equals the original number, okay? And then your second case is going to be 3 minus 4x equals the opposite. Well, the opposite of 23 is negative 23, okay? Once you get here, it is you pulling back your Math 1 skills and solving for x, okay? You always get rid of the number furthest away from x. So we're going to get rid of 3. So we're going to say minus 3. We get negative 4x equals 20. Divide by negative 4. And x equals negative 5. Now remember, x can be negative. Y can't be negative, okay? So until we check our answer, that solution is okay. Now you're going to do the same process again, except you're just going to do it with negative 23. So your answer is going to be a little different. So we're going to say minus 3 minus 3. We get negative 4x equals negative 26. Divide by negative 4. X equals 6.5. Okay? Now, before I box those in and call them an answer, we need to check our answer. I'm going to use Desmos, like I said before, so you can see my screen. Okay? So we're going to pull Desmos up. Now, to find the absolute value bars in Desmos, you go down to your keyboard down here, and it's the absolute value of A right there. So we are going to say 3 minus 4 times, plug in negative 5. Okay? And we got 23. And that's what we wanted. We wanted it to give us 23 when we plug it in. So negative 5 is a solution. The great thing about Desmos is I don't have to type that all over again. I can just interchange negative 5 with 6.5. So now I'm going to take that negative 5 and I'm going to change it. I'm just going to use this keyboard. 6.5. And I still got 23. So both these answers work. So we have two solutions here. So the answer to number 1 would be negative 5 and 6.5. Okay? All right. Number 2. Now when you look at number 2, you see the difference. Okay? This one is not isolated. We need to get rid of this 5 before we can even start setting up our cases. So we're going to subtract that 5 on both sides. Okay? And we get the absolute value of x plus 8 is equal to negative 3. Now, it's isolated, right? Anytime you get something isolated, even when we get to solving inequalities in the next lesson, a negative and an absolute value bar should always throw a red flag up, especially if it's isolated, okay? So we've already set up here that an isolated absolute value cannot equal a negative number. So this is isolated and it's saying it equals negative 3. Well, that cannot happen, so this would be a no solution. Okay? Easy breezy, no solution right there. Okay? All right. So, we move on. Number 3. Let's do number 3. So, number 3, again, it is also not isolated. Okay? So, we need to make it isolated, and what we see is that this plus 2 is on the outside, and we need to get rid of it. So we're going to say, just like we did with the 5, we're going to subtract a 2 on both sides, and we get the absolute value of 3x minus 8 equals 7. So this time we isolated it equals a positive number. So we're good, and we can set up our two cases now. So we're going to set it to the original number, and we're going to say 3x minus 8 is equal to the original number, and then we're going to say 3x minus 8 is equal to the opposite, which would be negative 7. And now we're going to get x by itself. So we're going to add 8 to both sides. and we get 3x equals 15. Okay, and then we have to get, we're still getting x by itself, so we're going to get rid of that 3 by dividing by 3. And x equals 5. Okay, next one, you do the same process, it's just you're going to get a different number because it equals a different number. So we're going to add plus 8. We get 3x equals 1. We're going to divide by 3, and x equals 1/3. Now again, we're going to check our answer, okay? And we're going to go to Desmos to check our answer. All right, so it's 3x minus 8. Okay, so we're going to do the absolute value of 3. I've done forgot it. It is 3x minus 8, and that's a 5. So we're going to say times 5 minus 8. I do believe that's right. Yes. Close. So that gave us 7, which is what the original answer was. Oh, sorry, I forgot the plus 2. Got to go back up and do the original one, so let's do the plus 2. But it does equal 7 right here, so that's fine. But it's always better to go to the original. So we're going to say plus 2, and we know plus 2 is 9. So that gave us the right answer, so we can go ahead and box in 5. Now let's try 1/3. So we're going to change 5 to 1/3, and we still get 9. So both these answers are a solution, and so our answer to number 3 would be 5 and 1/3. Okay? All right. Let's go down to the next row. So the next row, we're going to make it a little bit more difficult here. And if you look, there are 2 things here to make this that I need to get rid of to make it isolated. There's a -5 being multiplied. It is really key that you know what it's doing in between the absolute value and the number, because you remember you have to do the opposite to get rid of it. So it's really important that you know that this is -5 times the absolute value. And when you look over here to number 6, this is 7 minus the absolute value. So you solve those 2 different ways, okay? So it's really important you know the operations in between, especially those front numbers. It gets us a little confused every now and then. And then I have to get rid of this plus 2. Now, you're solving, so you're working backwards. So you get rid of addition and subtraction before you get rid of multiplication and division. So I'm going to subtract the 2 first. Now, do you see how this is equal to a -73? That is okay because it is not isolated yet, okay? You do not care about that negative until it is isolated. So let's isolate it first and see what we get. So that cancels. We bring down the -5 times 5x minus 5. And that's going to be -75. Now, we've already talked about it. That is saying, and if you have to say it in your head, say it in your head. -5x times the absolute value. How do you undo multiplication? Division. So we're going to divide by -5 here. All right, and I think that is 13 or 4, nothing. 15, -75 divided by -5, 15. Gives us 15, and it turns positive. So now I have the absolute value of 5x minus 5 equal to positive 15. And now it is okay because an isolated absolute value equals a positive number. So I'm going to draw a little squiggly so we don't get it confused with our cases. Now let's break it up into our cases. Case 1, the original number. 5x minus 5 equals positive 15. Second case, 5x minus 5 equals the opposite, which is -15. Now solve for x. We're going to add 5. I get 5x equals 20. Divide by 5. X equals 4. Same thing. Add 5. Add 5. We get 5x equals -10. Divide by 5. X equals -2. Okay? All right, so now let's check our answers. All right? let's see, I need to write it down so I don't keep flip-flopping back and forth between. All right, so we are going to go back and plug into our original answer the 4 and the 2, okay? So let's go to Desmos. We're going to go to Desmos, and we've got, so I've got -5, and then the absolute value of 5 times, our first answer was 4, and then -5, close the absolute value, and then we're going to say +2. That gives me -73, and that's what my solution was. So 4 is an answer. Now let's try -2. So I'm going to take the 4 and I'm going to replace it with a -2. I still get -73, so that also is an answer, okay? All right, number 5. Okay, so it is also not isolated. You have the -2 right here in front, and then you have a +5. So again, that's saying -2 times, so that's going to be a division to remove that -2, but we always get rid of the addition and subtraction first. So we're going to subtract the 5 first. Okay, so 13 minus 5 is going to be 8. So we have a -2, absolute value of 3 minus 5x is equal to 8. Then we're going to divide by the -2. And that's going to give us 3 minus 5x equals -4. Again, this is isolated, and it's equal to a negative. That cannot happen, so this is a no solution. Okay? All right, number 6 is also not isolated, okay? Now, this one's different, okay? It's not multiplication. It's not saying 7 times. It's saying 7 minus. So that means to get rid of that 7, I'm going to have to do addition or subtraction. Okay, so now that's a +7. So to get rid of a +7, I'm going to have to subtract 7 from both sides. Now, when you subtract that 7, that negative is still, this is still there. Okay, remember there's an understood 1 right there. So it's going to be -9 plus 3x is equal to -3. Okay. Now, remember, that's an understood -1. If you want to write that in there, you can. Let's see, let's write it in there. That's an understood -1. So we're going to divide by -1 here. And I get 9 plus 3x is equal to +3. Okay? So it is positive once it's isolated, so we're going to set up our cases. And we're going to say 9 plus 3x is equal to the original version. And then 9 plus 3x is equal to the opposite version. So we're going to subtract 9. I get 3x is equal to -6. Divide by 3. X equals -2. Do the same thing. Subtract 9. I get 3x equals -12. Divide by 3. X equals -4. Now, also checking your work helps you see if you made a mistake. Okay, so if it got it to where we plugged these numbers in and it didn't equal a +4, then maybe go back and recheck your work first. And then if your work's right, then it is not a good solution. Okay? So let's go to Desmos. So we're going to plug our -2 and -4 in. We have 7 minus, pull up the absolute value, and it's going to be 9 plus 3x, and our first x is -2. Whoops. And then that should equal 4, and it does. So the first answer is an answer. Now let's replace that -2 with a -4. And we still get 4 again. So both of these are answers, okay? All right, so 3 more. Now, number 7 is kind of a brain teaser, I feel like. But I tell my kids that as long as you have your steps and you know your rules, don't let something that's different throw you for a loop. So we're going to follow those steps no matter what, okay? So, is number 7 isolated? Yes, it is isolated. So we're good on that one, okay? So since it's isolated, we set up our cases, okay? I know it's equal to 2x and it's not equal to a number, but still treat that 2x as a number, okay? So the next step says to set up your cases, and one case says to set it to the original number, where the original number would be x minus 2 equals 2x. Then you have to change it to the opposite. Well, what's the opposite of 2x? Negative 2x, okay? So then the second one's going to be x minus 2 is equal to negative 2x. Okay, so it's the same steps, we just threw a little x in there, okay? So you still solve it the same way. So if you got 2 x's on one side, and you need an x on just one side. So we're going to first move our x's to one side. So we're going to subtract an x. I get negative 2 equals x. Well, that's done. Same thing over here. I'm going to subtract an x on both sides. I get negative 2 is equal to negative 3x. We're going to divide by negative 3. 2 negatives make a positive. So x will equal 2/3. Now, I need to check these answers, okay? Now, when you check these answers, there's an x on both sides. So you have to check both sides, and both sides have to give you the same number, okay? All right, so we're going to go to Desmos. And we're going to check both sides. So one side is the absolute value of x minus 2. So the first number is negative 2. So we're going to say negative 2 minus 2. We all know that's going to give us, yep. Let's close it. Okay. So I have to also plug in the other side. And the other side was 2 times x. So we're going to say 2 times negative 2. Now, do you see this? 1 gave us positive 2. See that? And then 1 gave us negative 4. Is positive 4 equal to negative 4? No, it's not. So negative 2 is not a solution. So we're going to mark this out. It is not a solution. Okay, it does not satisfy both sides. Now let's try 2/3. So we're going to replace our negative 2 with 2/3. Okay. And I still put my fractions in parentheses. 2/3. You really don't have to on Desmos. So 2/3 minus 2 gives us that. Now let's replace this 2 with 2/3 also. Now, this one, do you see how the first one gives us 1.333? Well, that's 1/3. So that's 1 1/3. This is also 1 1/3. It gives you the same number. So 2/3 is actually an answer. Okay? So if you were doing Study Island or Desmos or even a test or even the EOC, they would probably have a multiple choice question that said negative 2 and 2/3 was an answer. You would get it wrong because negative 2 is not an answer. It does not satisfy both sides. Okay? So my only answer is 2/3. All right, number 8. Number 8's a little different, but it's just refreshing your algebra skills, okay? So number 8 is isolated, so we don't have to do anything to get it isolated. So we're going to set the inside equal to the original version. And then we're going to set it equal to the opposite, which would be negative 1, okay? So you got to get rid of that denominator before you can even touch that x. So we're going to multiply both sides by 4. We get negative 3 plus x equals 4. You need to get rid of that negative 3, so we're going to add the 3 to both sides. And we get x to be 7. Okay? Same steps for the second case. Multiply both sides by 4. I get negative 3 plus x equals negative 4. Add the 3 to both sides. And I get x to equal negative 1. Now, let's check these answers before we box them in. Okay? You can grade your own paper by just checking your work. Okay? And just plugging it in and finding your answer. Now, we only have to plug it in on one side because there's only an x on one side. So we need both these, when plugged in, to give us a positive 1. So we're going to say absolute value. We need to, now with Desmos, so you saw how we're doing a fraction here. If you have more than one term on the numerator, you need to use parentheses, okay? So it's going to be, whoops, let's get back in there. There we go. So it's going to be parentheses, negative 3. Our first solution was 7, so it'll be negative 3 plus 7. Close your parentheses, then hit the division key. And it's divided by 4. And that gave us 1. So 7 is a solution. Okay. Now let's change that 7 to a negative 1. I'm just going to make negative 1. You can say minus 1, whatever. I'm just going to go ahead and make it simple. It gave us 1 also. So they are both solutions here. Okay. All right, the next one is another case that we have. So it needs to be isolated. If you look, this minus 1 does not belong. We need to get rid of that minus 1. Okay, so let's get rid of it. If I can, there we go. So I'm going to add the 1 to both sides. Now, negative 1 plus 1, that cancels out, right? And you're left with 0. Okay, now this is a special case because is there an opposite to 0? Remember we talked about why we said an absolute value. We don't say an absolute value can't equal, can only equal a positive, because 0 is neither positive nor negative. That's why I say an absolute value cannot equal a non-negative, or it equals a non-negative number, because 0 is neither positive nor negative. So I can't split into two cases because 0 only has one side to it. So there's only going to be one answer. So when you have an isolated absolute value equal to a 0, you're only going to have one answer. So we're going to say x divided by 2 plus 3 equals 0. So we solve. We subtract the 3. I get x divided by 2 equals negative 3. Multiply both sides by 2. X equals negative 6. Okay? Last one to check our answers. Let's check it. So I'm going to say the absolute value of x divided by 2. So we're going to say negative 6 divided by 2. Okay. It really don't matter what that negative is. So we're going to get out of that and then say plus 3. Close your absolute value bars. It equals 0, which is what we wanted. So negative 6 is the solution. Okay. So that is it for the examples. But I do want to scroll. Here we go. Let's sum it up. Okay. So when solving an absolute value equation, you can have 3 cases. Okay. So the first case is the one we just did. When you have an isolated absolute value equal to 0, there is only one solution. Okay, so see how it equals 0? There was only one solution there. Your next case is when an isolated absolute value equals a negative. An isolated absolute value can't equal a negative, so this would be a no solution answer, okay, because it cannot equal that negative. And then your last case would be when an isolated absolute value equals a positive number. That can happen. And that's going to give you two solutions. And then it shows you down here how to solve them. Okay? So you can have 3 different types of solution. You can have one solution, you can have no solution, or you can have 2 solutions. Okay? And that is it for solving absolute value equations. Thanks, guys.